Question 3. Some students wanted to investigate how craters form. They dropped two different balls, a golf ball and a table tennis ball, so a little ping pong ball, from a height of 2 meters, both of them onto a container filled with flowers. You can see in the diagram just to the side. Calculate the weight of the golf ball. Well, the weight is the weight force, or the force due to gravity on the golf ball, which would be the mass of the golf ball times by gravity. So the mass of the golf ball is 0.046 kilograms, gravity is 10 meters per second squared, or 10 newtons per kilogram, so that will give us a weight of 0.46 newtons. Okay, moving on. B, the image shows, the image you can't see, the example of a crater produced by the golf ball. We can do a quick sketch. Something like this. There we go, there's our crater, there's our sand. The students found the golf ball always produced a deeper crater than the tennis ball, which is not surprising on the common sense front. Explain why the golf ball produces a deeper crater than the table tennis ball, even though the balls are the same size and shape and drop from the same height. Okay, so same size and shape is kind of irrelevant. Okay, they're the same size and shape, so they will displace the same amount of sand if you push them flat. So that probably doesn't have a lot to do with it, so we're going to ignore that. And drop from the same height. So from the same height, there's two ways to look at this. One, if you look at the energy, it's going to have more gravitational potential energy for the one with the greater mass. Okay, remember the height is the same and the gravity is the same, so they'll have the same GH part, but it's only the mass that affects it. So the golf ball being heavy will have more gravitational potential energy. That means when it hits the ground, all of that gravitational potential energy has been converted to kinetic energy. So there'll be more energy for the golf ball to displace sand with. That's a big part. That's one way to look at it. The other part I was going to look at is the speed. Okay, you've got to be really careful here, because the speed of both of them when they hit the sand at the bottom is going to be the same. Okay, that might not make sense. You think, why won't the heavier ball, the one with more mass, pick up more speed? And the answer is they're both accelerating under the same acceleration. Okay, 9.8 meters per second for every second that they're in the air, falling. So they have the same velocity when they hit the bottom. So then again, we can come back to the energy, and we can look at the kinetic energy, half mv squared. So this time again, the velocity is the same, that's not going to change anything, half is the same, but the mass is different. And it's going to be the same factor by which it's different for the potential energy at the top. So as all that potential energy again converts to kinetic energy, or you can just go straight to the kinetic energy formula and say they picked up the same velocity, but the one with the larger mass will have more energy. And then you have to say that more energy to move the sand, or the flower, or whatever it is. I think it's flower, isn't it? Okay, so that's a key thing. The other idea, which you could potentially talk about, is pressure. And I'll just scoot over to the side a little bit for this. Remember, the pressure equation is the force over the surface area. Okay, same surface area, however one of them has a higher force because it's got a higher weight force. See how that works? And the other one is lower, so therefore the pressure will be different. The one with the greater pressure will displace more flour because it will dig in deeper with that greater pressure. Okay, and if it goes in deeper, it has to displace more. Now, moving on to the next question, we've got conservation of energy. Calculate the speed of the golf ball when it hits the flower. Okay, so they haven't spoken too much about energy prior to this, but if you did follow through with the gravitational potential energy, kinetic energy kind of idea, you would now approach this question and be sweet as. Because if you're looking at the speed of the golf ball when it hits the flower, you've got enough information to calculate the gravitational potential energy, mgh, for the golf ball. We've got the mass of the golf ball, we've got gravity, and we've got the height is 2 meters. And all of that energy is converted to kinetic energy just before or as it hits the flower, which is half mv squared. Okay, so we can do a calculation. There's actually two ways we could do this as well. we could do our calculation of MGH, and then once we've got that that value there, that's going to equal our half mv squared, and we can use this to rearrange for v, because we know the mass again, remember. So we rearrange for v, which would be v equals 2 times that potential energy that we had, divided by the mass, and then the square root of all of that. Okay, now there is a slightly quicker and easier way, which I'll show you because it's really cool, and it also shows, we'll get to that. We know that MGH equals half mv squared. So this is a separate thing. MGH is half mv squared. We can cancel out the mass because it's the same, and we will see that the velocity when we rearrange is just square root of 2gh. What's interesting about this is it shows that the final velocity is independent of the mass. So there's no mass related to the final velocity. That means both the golf ball and the ping pong ball are going to reach the same speed, the same velocity, because they undergo the same force due to gravity and the same height that they're dropping from. Interesting, eh?